cosecant is the reciprocal of sine. So we should be seeing a sinusoidal wave going directly between these points, where it changes directions. And so that's one way of doing this, is if you graph this black curve that I've made, and this one should actually touch more here, but you get the idea. If we can create the equation for the graph of this curve, then we just replace sine with cosecant. Okay, so to figure out that sinusoidal wave, we need to first know where the midline is. And the midline is halfway between this point and this point, because you can think of this as like the upper cutoff, and this is the lower cutoff of the sinusoidal wave. So the midline is right here at 1. I should start with this. Y equals A times sine B parentheses X minus C plus D. Although I've been seeing this be D and this be C, doesn't really matter though. Okay, sine usually starts at y equals 0 at the x-axis for the midline, then waves like that, but it's been vertically shifted up 1. So we need a plus 1 at the end for D. That's the vertical shift. It's 1 up from the x-axis. And then the amplitude is how high or how low we go from the midline. So if this is our midline, sine wave goes up 1 and down 1, so that's A. It's just 1. You don't have to write a number there if you don't want it. Now B is determined by the period, and the period is how long it takes until we start repeating ourselves. So we start at negative 5 pi over 4, and then we repeat ourselves at 11 pi over 4. So if you add those two distances together, that's 16 pi over 4, which is 4 pi. So the period is 4 pi. So to find out what B is, we can use this little formula. The period of sine is always 2 pi divided by B. We just found out the period is 4 pi though, so we can put 4 pi here and then solve that equation for B. You can multiply B to both sides, divide 4 pi from both sides. If you solve that, you should get B as 1/2. Oh, so I wrote B, but that's a 1/2. And now C is if there's any sort of horizontal shift that's occurred. Sine usually starts at 0, 0. This is the sine wave with no horizontal shift, no vertical shift. It goes up and down between 1 and negative 1. I just noticed that R is actually, it starts at the midline, just like this one does. This is the midline. Okay, so it starts at the midline, so it looks like there's no horizontal shift. But it actually starts going down instead of starting by going up and then down. So we need a negative on the outside here. So no horizontal shift, we just need that negative sign. So putting that all together, it's negative sine 1/2 x plus 1. And then we could go to desmos.com to graph that, just to double check. Desmos.com/calculator, and we said y is negative sine 1/2 x. And then it's plus 1, I think. Should be seeing the same graph. That's that black line. Negative pi to 3 pi. Doesn't sound right. Oh shoot! No, I guess I'm wrong. There has been some sort of horizontal shift that's occurred. I shouldn't have relied so much on my black sketch, because that made it look like it perfectly crossed the midline, but it obviously doesn't. Okay, so we got to back up. I've messed up C here. Let me show you what we have. Everything else is right. Equals negative sine 1/2. There is a horizontal shift, and I should know better than to rely on my terrible drawing. To find out what that shift is, that C, all you have to do is plug in either of those 2 points that you're given. I'm going to plug in 11 pi over 4 for x, 2 in for y, and solve that equation. We got 1/2 times 11 pi over 4 minus C plus 1. Okay. So we can distribute that 1/2. So that makes 11 pi over 8 minus 1/2 C plus 1. And then let's subtract that 1 from both sides. So we get 1 equals negative sine 11 pi over 8 minus 1/2 C. And so there's only one angle that would make sine equal -1, right? Because what we really want is to plug in a number in for C so that we get a -1 out of here. That way our negative would make a positive. To figure out what that angle is, you can remember that sine is the y coordinates in the unit circle. So here, at the initial side, a 0-degree angle, that's a y coordinate of 0. So sine would be 0 there. Sine is +1 here. Sine is 0 here. And then this is -1. So we need a 270-degree angle, or in other words, in terms of radians, that's 3 pi over 2. So we need this whole thing on the inside to equal 3 pi over 2 in order to get the right horizontal shift. Okay, so this is 3 pi over 2. I'm going to get common denominators so I can subtract that from both sides. Multiply the top and the bottom by 4, so I got 12 over 8. Subtract that 11 pi from both sides, so you get -1/2 c equals pi over 8. If you multiply -2 to both sides, we get c equals -pi over 4. So there's our horizontal shift. It's plus pi over, you could say minus a -pi over 4. Here it is, putting it all together. We said it's negative sine, 1/2 x, and then minus a -pi over 4. I'm just going to put plus pi over 4. Plus 1. There it is. Okay, so now we figured out the equation for this wave. Cosecant is the reciprocal of sine. So all you have to do for your final answer is y equals negative cosecant, CSC, 1/2 x plus pi over 4 plus 1. So that is our final answer. This is the black curve that we talked about, but this is the blue line that we were asked to graph in the first place.